This is my trigonometry course. Today we're going to prepare for the first test of the course. If you haven't done the homework completely incorrectly from the last class, do that homework before watching this video. In my previous courses, I say it every time that we have a test, so you probably heard me say this before, but for those who don't know, there are some subjects where you can study an hour or two the night before and ace the exam. Well, math doesn't work that way. With math, you need at least 2 or 3 days, maybe even longer, to prepare for an exam. But it doesn't matter how many times you tell students to study for a test, they're not going to do it. So in order to force you to do at least some studying, we're going to do a practice test right now together, and I'm going to give you a practice test for homework. And these tests will not only force you to do at least some studying, but they will also familiarize you with the format of the test. So we're going to get into that. Now, you do need to memorize this information. You can take a picture of this information if you want. We have the graphs of the basic functions and the definitions of the functions at the left, and at the right we have the special triangles. But just be aware, when you take the test, I'm not going to allow you to have that information right in front of you. You need to have that information memorized. And I know it's intimidating to have to memorize all that, but it's really not that big of a deal. Just surrender yourself to the fact that you're going to need to memorize things in school. So, as usual, you need to write your name, the date, and the course title, Trigonometry, at the upper right. And, of course, you need to show work and rectangle your final answers. You'll need a calculator. Be sure that your calculator is in degree mode. It should be in degree mode, but if it's not, push the mode button at the upper left on your TI calculator and use the arrow keys to change to degree. If you're using an iPhone, rotate to landscape mode and make sure that it says rad at the bottom left. If it says DEG, push that DEG button and it'll change to rad. So it's the opposite of what you would think. Rad means radians, which we haven't learned yet. We're going to go over that towards the end of the course. But you want to be in degree mode, so it should say rad. Now, if you're using a different calculator, you'll have to look at the user manual for that. Each problem is worth 4 points for a total of 100 points. So there's 25 problems. So let's go ahead and get started. Now, I want you to do these problems on your own. Don't just watch me do the problem. I want you to try this problem, and if you get stuck, that's okay. We're preparing for a test, so if you get stuck, that's okay. You may not remember some of this stuff. That's the whole purpose of this practice test, is for you to get used to the material, so there's no problems on the test. Now, the actual test is very, very similar to this test that we're about to take and the test I'm going to give you for homework. So you can't say that you were caught off guard. That's kind of one of the main purposes for these tests. So it says here, find the values of the following expressions without a calculator. Write exact answers. Draw each angle in standard position. Write the measure of each angle and the measure of its reference angle along with the corresponding right triangle, and so on and so forth. So go ahead and try number 1 and draw the angle. You don't have to have different colors, but see what you can do. And if you have trouble, again, that's okay. We'll do it together. When you come back, we'll see what the answer looks like. Okay, we're back. So I'm going to draw a 120 degree angle, and I don't really care if that angle is exact. You don't have to get a protractor. The purpose of this is not to draw an exact angle. It just has to be it has to terminate in the correct quadrant. So that's 120 degrees, and we need the reference angle, so we subtract 120 from 180, and we get 60 degrees. Now, you don't have to write this other angle up here, but I'm going to go ahead and do that just so we can see what type of triangle this is. And you can find this angle by subtracting 90 and 60 from 180 degrees, right? Because all the angle measures in triangles, the three angle measures add up to 180 in any triangle. So now I want you to write the relative side lengths. The side opposite 30 degrees is always x, but in this case it's going to be negative x. How do I know that? Well, because this side is to the left of the y-axis, and it's horizontal, so it must be negative. And this side is going to be positive x root 3. That side, that's always opposite 60 degrees, and the hypotenuse is going to be 2x. And maybe we can draw this arc a little smaller just so we can see that side length better. So all of that is to simply find the sine of a 120 degree angle. Now, when you go into upper mathematics, you're going to be expected to do all this in your head. And I know that seems kind of daunting, but you're going to get used to these problems to the point where you really can do that easily in your head. But for now, I want you to show this so that we can see why a 120 degree angle would give us a sine value equal to what we're about to find. So the sine of a 120 degree angle is the side opposite the green reference angle divided by the hypotenuse. And that simplifies to root 3 over 2. So there you go. Alright, if you got that one right, good. Go ahead and try number 2. Now that's a negative angle, so you're going to have to rotate clockwise rather than counterclockwise. Try number 2. When you come back, we'll do it together. Okay, we're back. So I'm going to rotate clockwise because it's a negative angle. Then we have our corresponding right triangle in the first quadrant. And we need to subtract 315 degrees from 360 degrees to get our reference angle. We'll get 45 degrees. And hopefully you recognize this as a 90 degree angle, or 90 degree triangle. So now we're going to write the relative side lengths. Again, this is all stuff that you should have memorized. At least you're going to need to have it memorized for the test. These sides are both positive because we're in the first quadrant. And so now we're ready to write the answer. Secant negative 315 degrees is equal to the hypotenuse divided by the side adjacent the green reference angle. And so we have root 2. So if you got that right, excellent. Okay, go ahead and try number 3. Now be aware that when you have quadrantal angles, meaning angles that are multiples of 90 degrees or 0 degrees, you're going to have a collapsed triangle. And notice what it says here. If a triangle is collapsed, then you cannot draw it. Obviously you can't draw a collapsed triangle. In this scenario, draw only the angle. So you're going to write the answer, but when it comes to drawing the angle, you can draw the angle itself, but there is no reference angle and there is no triangle because the triangle is collapsed. Now, in order to find the tangent value of a 90 degree angle, you need to use these graphs over here. Whenever you have quadrantal angles, the best way to find the value of the trigonometric function is to use these graphs. So make sure you get a picture of these graphs. You're going to use the tangent curve down here. And while you're at it, I'm going to give you one more chance to take a picture of all this information. You need this stuff right in front of you. you're going to have to get used to you're going to have to start memorizing that stuff, because you're going to need to memorize it eventually. Try number 3, and when you come back, we'll do it together. Okay, we're back. So if you look at those graphs you have right in front of you, you see that tangent 90 degrees is actually undefined. 90 degrees is where the dotted asymptote occurs. There is no red graph on that part. So the answer is it's undefined. So sorry if I tricked you on that one. Tangent 90 degrees is actually undefined. You're not going to get very many of those types of problems, but we did have some of those problems in the homework, so you may get a problem like that. So just to be clear, 90 degrees is where that yellow asymptote is. There is no red graph that crosses that yellow asymptote, so tangent 90 degrees is actually undefined. Now we are going to draw the angle, though. The angle is going to be there. So if you got that one right, excellent. Okay, so I want you to try number 4, and when you come back, we'll do it together. Okay, we're back. So we have 90 degrees, 180 degrees, and then a little bit more gives us 210. So to find the reference angle, we subtract 180 degrees from 210 degrees. So we have a 30-degree reference angle. And x is always opposite the 30-degree reference angle. 2x is the hypotenuse, and x root 3 is the other side, but it's going to be negative in this case. So, and by the way, we know this is a 30, 60, 90 degree triangle because we recognize the angles, that the reference angle is 30, this angle is 90 degrees, so it must be a 30, 60, 90 degree triangle. That's how we know the side lengths. So now that we have all that information there, we can find cotangent 210 degrees. That is the side adjacent the green reference angle divided by the side opposite. So we get root 3. So if you got that one right, perfect. Okay, go ahead and try number 5, and when you come back, we'll do it together. Okay, we're back. So this angle is going to be in the first quadrant. It's 45 degrees. It's going to look something like that. And in this case, the reference angle is the actual angle. And you don't have to draw this angle, but that's going to be 45 degrees. I'm going to go ahead and draw the 60-degree angle here. And you don't have to draw an arc if you don't want to. Sometimes it might seem helpful. Other times you may not want to because there's not enough room. So this is a 45, 45, 90-degree triangle, and these are the relative side lengths. So now we're ready to find the value of cosine 45 degrees. Cosine is defined to be the adjacent side divided by the hypotenuse. The x's are going to cancel out, and if we multiply both sides of the fraction by root 2, we get root 2 over 2. So we rationalize the fraction. If you forgot to rationalize, that's okay. Go ahead and do that now. So if you got that one right, perfect. Now 270 degrees is a quadrantal angle. So you're going to need to look at your cosecant curve if you have that in front of you. So you're looking for if the x value is 270 degrees, then what is the corresponding y value on your red graph? So try number 6. When you come back, we'll do it together. Okay, we're back. So we're going to go out 270 degrees. So 90, 180, 270, and you see the corresponding point is there, and the y value of that point is -1. That's this point right here, if you can see that. So cosecant 270 degrees is -1. That was pretty easy. Let's draw the angle. So 270 would be about there. So if you got that one right, excellent. We have another quadrantal angle. 180 degrees is a multiple of 90, just like 270 degrees. So you're going to need to use your sine curve. So if the x value of the graph is 180 degrees, and what is the corresponding y value of the point on the red curve? Try number 7. When you come back, we'll do it together. Okay, we're back. So if you go out 180 degrees on the x-axis, you get to that point on the red curve, and the y value of that point is 0. So sine 180 degrees is simply 0. And we can draw that angle in standard position. There you go, 180 degrees. Now notice that we're not drawing arrows. Technically, angles should have arrows, but the reality is most of the time we don't draw arrows when we're dealing with angles. That's just an artifact from our geometry course. Okay, so now we have a different type of problem. It says find the values of the expressions below with a calculator. So we need our calculators for this. Round to the nearest thousandth. So again, you need to make sure you're in the right mode for your calculator. If you're using a graphing calculator, you want to push the sign button and then enter 127, 127, and press the enter button. If you're using an iPhone, you want to enter 127, then push the sign button. And we're looking for approximate answers, so write an approximately equal to symbol. We have 0.799 because we're going to round up. So if you got that one right, good job. Go ahead and try part 2. See if we get the same answer. Now, if you got a different answer on your calculator, that means you're probably in the wrong angle mode. Push the mode button at the upper left on your TI, or look at your user manual if you're using a different graphing calculator. And if you're using the iPhone, make sure it says RAD when you're in landscape mode. Rotate the phone to landscape mode. It should say RAD at the bottom left. If it says DEG, then press that button so it changes to RAD. So try part 2, find tangent 35 degrees, and when you come back, we'll do it together. Okay, we're back. So I got approximately 0.7, and that's rounded off to the nearest thousandth. So if we got that right, good. Okay, go ahead and try number 9. Number 9 should be fairly easy. And when you come back, we'll do it together. Okay, we're back. So we're finding cosine of the angle A. And remember, cosine is the adjacent side of the angle, which is √6. There's two sides that are adjacent, but this side is never called the adjacent side. It's always called the hypotenuse. So root 6 over the hypotenuse. Adjacent over hypotenuse is the definition of cosine. So if you got that one right, good job. Cotangent beta. Well, cotangent is defined as the side adjacent beta, which is this side. This side is also adjacent, but it's never called the adjacent side. It's always called the hypotenuse. So cotangent is the adjacent side divided by the opposite side. So we have 3 over root 15. And we're going to multiply both sides of the fraction by root 15 in order to rationalize the denominator. And if you're having trouble rationalizing denominators, you can go back to the first, or actually the second class, I believe it is, of this course, or you can go to my intermediate algebra course or my beginning algebra course. We talk about how to do that. Now, there's an extra complication here. We need to reduce 3 over 15. If we divide the numerator by 3, we get root 15. If we divide the denominator by 3, we get 5. So there you go. Okay. If you got that right, perfect. Let's try number 10. It says the measure of an angle in standard position is written below. Find the measures of 3 coterminal angles in standard position. So we have this angle here. We want to find coterminal angles. Now, you don't have to draw the angle, but if you drew it, it would look something like this. That's 240 degrees. I mean 244 degrees roughly. And if you want to find a coterminal angle, all you have to do is start where you left off on the terminal side of the angle and add 360, and you get right back to where you stopped, where you started. So that's a coterminal angle because the terminal side stops at the same place you started. But you can also go in the clockwise direction. If you go this way as the counterclockwise, you can go in the clockwise and subtract 360. So long story short, you can add or subtract multiples of 360 degrees. So let's first add 360 degrees. And don't be afraid to use your calculator. That's okay to use your calculator if you don't want to do that in your head. We get 604 degrees. So that's the measure of a coterminal angle. We can also subtract 360 degrees. So 244 minus 360 is negative 116 degrees. And if we add 360 to 604 degrees, we can find another coterminal angle. And there's actually an infinite number of answers. So if you got different numbers, they may still be correct, as long as you added or subtracted some multiple of 360. So we have 964 degrees if we add 360 twice. So if you got numbers that were coterminal, the measures of angles that are coterminal, good job. These are just some possible answers. Okay, so it says here for problem numbers 11 through 15, draw the angles that are solutions to each equation in standard position, as well as their corresponding right triangles, and write all 3 interior angle measures of each triangle and the relative side lengths. So in this problem, I'm actually asking you to write all the angles in the triangles. You don't really have to do that in order to find the answer. But it helps us to see what type of triangles we're dealing with. So we have this equation, and we would need to find the angles that you can plug in to that equation to make it true. So what angle measures can you plug into the secant function so that we get negative root 2? Well, the first thing we need to do is figure out what quadrants our angles are going to terminate in. Secant is negative. So what that tells me is we have one angle that terminates in the second quadrant, and we have another angle that terminates in the third quadrant. Now, I just drew angles that are multiples of 45. These would probably be 45, 45, and 90 degree triangles if you actually looked at the angles and measured them. So the triangles are really not exact, but they don't have to be exact. The whole purpose of the triangle is just to give you an idea of what's happening. It turns out these actually are going to be 45, 45, 90 degree triangles because we recognize this ratio. So anyway, we have this angle and this angle. Those are the angles that we're looking for. Those are the solutions. Now, how do we know what the angles are? Well, we recognize, well, first of all, how did I know that the triangles were in the second and third quadrants? Because secant is negative. Secant is the hypotenuse over the adjacent side of the reference angle. The hypotenuse is always positive, so the adjacent side must be negative for this to work. So in these cases, the adjacent side is negative. So I recognize this as the ratio corresponding to a special triangle. It's a 45, 45, 90 degree triangle. And I know the relative side lengths. Again, that's all stuff that you're going to have to memorize. So we have negative x over here, x root 2. And of course, the hypotenuse is x root 2 over here. And the reference angles, of course, are going to be 45 degrees. They both have the same reference angles. And that means that we're going to subtract 45 from 180, and we get 135 over here, and add 45 degrees to 180, and we get 225 degrees over here. So again, we can know all of this just by looking at the ratio, the sign of the ratio, and that may not look like a ratio, but technically it's negative root 2 over 1. That's why we're calling it a ratio. So notice that these sides again are negative. That's how we know that the triangles are in quadrants 2 and 3. And so we're basically done with the problem at that point. Theta is equal to 135 degrees or 225 degrees. And we found those without the calculator because we knew that that we could do that given this special ratio. Okay, try number 12. You're going to find the angle measures you can plug into this equation that will give you root 3 over 2. So try number 12. When you come back, we'll do it together. Okay, we're back. So this ratio is positive. So cosine has to be positive in the first quadrant and the fourth quadrants. Now you can draw any right triangle. It doesn't really have to be the exact right proportions. That's not the point of this, to draw a perfect right triangle. The point is just to get an idea of what or where the triangle is and why the angle measures that we're going to find are solutions to the equation. So this angle here in the first quadrant is the actual angle that we're looking for, and that's going to be 30 degrees. So the reference angle is 30 degrees. And how do I know that? Well, I recognize this ratio as a 30, 60, 90 degree triangle. The only thing we have to figure out is what is the reference angle? Well, cosine is the adjacent side divided by the hypotenuse. So that means this side must be x root 3, which means that this side is x. 30 degrees is always opposite x. And the same is true over here, except we have negative x because the triangle is going down. It's below the x-axis. So one of our angles is 30 degrees. The other angle is going to be whatever this angle is, and we can find that angle measure by subtracting 30 from 360, and we get 330 degrees. So those are our solutions. Theta is 30 degrees or 330 degrees. So if you got those answers, perfect. Okay, go ahead and try number 13, and when you come back, we'll do it together. Okay, we're back. So this is a negative number here, so what that tells me is that the triangle must be in the well, actually it must be in the second quadrant or the fourth quadrant. So again, your triangles don't have to be perfect. I don't really care if it looks like a 30-60-90 or a 45-45-90 or you know, just as long as it's a right triangle and it's in the correct quadrant and the angle's in standard position. So tangent is the opposite side over the opposite over the adjacent. So that tells us what the relative side lengths are going to be. Obviously this is a 30-60-90 degree triangle, and the angle opposite x root 3 is always 60, so 60 degrees. That's the reference angle, and we're going to subtract 60 degrees from 180 to get the actual angle that we're looking for, 120, and then over here we're going to subtract 60 degrees from 360 to get 300 degrees. So now we can write the solutions. Technically we already wrote the solutions, but we can just rewrite them down here so people know exactly what the final answers are. So there you go. Theta is 120 degrees or 300 degrees. Now there's actually an infinite number of solutions to this equation, but we're only interested in the ones between 0 and 360. So, if you got that answer, excellent. Okay, on to number 14. Now notice that 14 is asking for all of the values of theta. There's an infinite number of solutions to this equation, and any equation really that looks like these equations. In the previous problems, we're only interested in the ones between 0 and 360. Now we want all of them, so you're going to have to write an equation with n. Remember n? N can be any integer. So try 14. If you have trouble with that, that's okay. See if you can do it, and then we'll do it together when we come back. If you forgot how, that's okay, but try number 14. Okay, we're back. So because this ratio is positive and the cosecant function is the hypotenuse divided by the opposite side, I know that my triangles must be in the first and second quadrants. So it's the first quadrant and the second quadrant. And you know, this is one example where it might be better just to draw the angle a little smaller, just so you can fit a triangle there. Again, it really doesn't matter if it's exactly a 30-degree angle or a 60 degree or whatever you're looking for. So the hypotenuse is 2x, and the opposite side is x root 3, because that's what that ratio tells us. And the location of the triangles, they tell us what the signs are. And this side has to be positive. The only way that's going to happen is if the triangles are in the first and second quadrants, because that side is the opposite side. So the angle across from x root 3 is always 60 degrees, so the reference angle is 60, and this angle would be 30. You don't have to write that, but you can if you want. And so we have everything that we need to find the angles we're looking for. This angle down here is actually 60 degrees, and this angle is 180 minus 60, which is 120. But notice it says find all values of theta. There's an infinite number of solutions to this equation. If you start from 60 and then rotate 360 degrees all the way until you get back to where you started, that's a coterminal angle. So you can add multiples of 360 to our answer. That's 360n. As long as n is any integer, you'll get a coterminal angle. And so that represents all the angles that terminate in the first quadrant. You also need an equation to represent all the angles that terminate in the second quadrant. And of course, again, you're going to add or subtract multiples of 360 degrees. And that'll give you coterminal angles with this angle here. They're all going to terminate in the second quadrant. So those are the solutions. If you're a little rusty on how to write those equations, that's okay. But now you know. So if you got that answer, good job. Okay, go ahead and try number 15. Now, with 15, remember, you can actually combine the two equations into one. Now, if you forgot how to do that, that's okay. Just write two equations, and then I'll show you how to combine them to one after you're done. So try number 15, and when you come back, we'll do it together. Okay, we're back. So notice that cotangent is positive 1, so that means that our triangles are going to be in the first quadrant and the third quadrant. And this ratio is x over x, so you may recognize that ratio. The reason that we know that the triangles are in the first and third quadrants is a positive divided by a positive is a positive, and a negative divided by a negative is a positive. So we know these are 45, 45, 90 degree triangles. So we can write the angles. And of course the hypotenuse is x root 2. Okay, so one solution is 45 degrees, and another solution is, that would be 225 degrees. We have to add 45 degrees to 180. So let's write the final solution. So again, you can write two equations, and technically those equations are not wrong. But if we move this graph and try to superimpose it, you see that that purple line there, or let's highlight this line. You see this yellow line? It's a straight line. So that means from here, from this terminal side to this terminal side is just 180 degrees. So you can keep adding 180 again and again and again, or you can keep subtracting 180 again and again and again. So we only need really one equation. So theta is equal to 45. You can use 45 or you can use 225. It doesn't matter. Plus 180n. We're just going to add 180 to get to the third quadrant solution. Then add 180 again to get to a coterminal angle in the first quadrant. Or we can go in the other direction. We can subtract and then subtract again. Subtract 180, subtract 180, and keep going on and on. And of course, n is any integer. So if you were a little rusty on how to combine the two equations, we had one equation from 225 and one equation from 45. You can combine them to make this equation. If you're a little rusty on that, that's okay. If you got that right, good job. Okay, go ahead and try number 16. Now you're going to need the sine curve right in front of you. The sine curve looks like this. You're going to need that curve right in front of you. Because this is going to be a ratio corresponding to a collapsed triangle. So try number 16, and when you come back, we'll do it together. Okay, we're back. So if you look at the sine curve, you see that it's 0 here, here, and here. So what are those angles? Well, this angle is 0, this angle is 180, and this angle is 360. How do I know that? Well, if you're looking at the curve right in front of you, you can see it's right there. So again, you're going to have that curve memorized. So 0 degrees, 180 degrees, and 360 degrees are the solutions. And the only reason that 0 and 360 are solutions is because it just so happens that our inequalities say less than or equal to. Sometimes they don't say equal to, so you may have to drop one of these numbers. But if you got that problem right, good job. Again, if you're a little rusty on these problems, that's okay. That's the whole point of this practice test. Go ahead and try number 17. Again, you're going to need the cosine curve, or excuse me, the cotangent curve, which looks like this. There's asymptotes. The asymptotes are the yellow lines. It's supposed to be straight lines. So you want to figure out where cotangent is equal to 0. In other words, where the red graph crosses the x-axis. Try number 17. When you come back, we'll do it together. Okay, we're back. So the graph crosses here, here, and here, and it crosses in an infinite number of places, but we only care about theta values between 0 and 360 degrees. So that would be 90 degrees. That's this one here, and 270 degrees, that is this one here. Again, you can see this on your graph. Now, by the way, you don't have to graph these, because that would be kind of tedious. But you don't really have to show any work. You can actually do this in your head for these particular problems. I'm just not going to require you to show any work on that. Okay, so on to number 18. Now, again, we have a collapsed triangle, a quadrantal angle, just like we did it for these problems, but now you're going to have to find all of the solutions to the equation, not just those between 0 and 360, but all of them. So see what you can do. You're going to have to get your cosecant curve, and when you come back, we'll do it together. Okay, we're back. So if you look at the cosecant curve, it's going to look something like this. And if you look for all the points on the red curve that have y values equal to -1, you'll see that that's a point right there, and that point is at 270 degrees. my graph isn't exactly that great. Probably should be more like this. Your graph doesn't really have to be perfect. And of course we have asymptotes coming down like so. Maybe use a different color. These are the asymptotes. But then you can add another, you can add 360 degrees and get to the next number. So let me draw all the asymptotes. You can just keep going. The graph repeats. And again, this graph isn't drawn very well, but that's not the point of this. But you can just keep adding 360 again and again and again. So 360 to get to there, 360 to get to the next part. You can subtract 360 to get to the next point at the left. So you want to say 270 degrees plus multiples of 360. You can subtract 360 if n is negative, or you can add it if n is positive. And of course, n is any integer. So that is the solution. So if you got that right, perfect. Again, we're reviewing things, so if you're having a little trouble with this, that's okay. This is all review to help you prepare for the exam. So let's try number 19. It says, for problem numbers 19 through 21, use a calculator to find the degree measures. Draw each angle in standard position, the corresponding right triangle, and the reference angle. So this is a ratio that we don't really recognize. So we have to use a calculator. But we do know that it's obviously negative. So sine is opposite over hypotenuse. The hypotenuse is always positive. So that means that the opposite side must be negative, which means that the triangles must be in the third quadrant and the fourth quadrant. We don't have to write the relative side lengths. We actually could write them because we can just use a Pythagorean theorem and find all the actual side lengths, or at least the relative side lengths. But the problem doesn't really say to do that. We need to find the reference angle, and again we have to use a calculator to do that. So what do you enter into your calculator? You enter this here. It's called sine inverse. If you're using a TI-84 plus, push the blue button at the upper left, and then push the sine button, then actually -4, push the negative button with the parentheses around it at the bottom right, and then 4 divided by 5, and then the enter button, and you should get approximately negative 53.13 degrees. So why is the calculator giving us a negative number? And by the way, if you're using an iPhone, you want to enter this, push the plus minus button after entering 4/5. That'll change it to a negative. Then you're going to press this button here, and you're going to have to push the second button at the upper left to change it, to change sine to sine inverse. Why did the calculator give us a negative number? Well, because your calculator is programmed to give you the angle that is closest to 0. If sine is negative, then that means our triangles have to be in the third and fourth quadrants. The closest positive angle to 0 would be this angle here, if we rotate all the way around to the third quadrant. But there's a negative angle that's closer. If we do a negative angle here, it would be in the third quadrant. That would be an obtuse angle. But if we do a negative angle down here, you see that it's much closer to 0. So it gave us this angle, negative 53.13. That's rotating clockwise. So that's why the triangle gives us that angle, that negative angle. But regardless of whether it's negative or positive, in this case, that number is the reference angle. So we can go ahead and write the reference angle there. And we can use that number to help us find the actual angles, because this is not one of the angles we're looking for. We're looking for angles between 0 and 360. So let's add that angle to 180. And be careful of your sign. If you have a negative number in your calculator, then you want to add negative 180. However you want to do it, but long story short, your angle should be 233.13 degrees. And we're going to subtract 53.13 from 360 to get the next angle. So that's going to be 306. 306 point, we can say 87 degrees. So those are the solutions. So in that case we had to use a calculator. So theta is equal to 233.13 degrees, or 306.87 degrees. So if you got those answers, excellent. If you had a little trouble, that's okay. Sometimes your calculator gives you the answer, sometimes it doesn't. In this case, it didn't. In problem number 20, your calculator actually is going to give you an answer. The problem is it's not going to give you the reference angle. You have to actually use the number your calculator gives you to find the reference angle. If you have trouble, that's okay. But try number 20. See if you can do it, and if you can't, that's okay. We'll do it together. All right, we're back. So we're going to use the calculator. We're going to find cosine inverse of negative 0.44. And so in my calculator, I'm going to push the blue second button at the upper left with my TI-84 plus, then the cosine button, then the negative button at the bottom right with parentheses around it, then 0.44, and enter. And we get approximately 116.1 degrees. So that is not the reference angle. Now I know that our triangles are going to be in the second quadrant and the third quadrant. How do I know that? Well, because cosine is the adjacent side divided by the hypotenuse. The hypotenuse is always positive. So that means the adjacent side has to be negative in order for the ratio to be negative. So let's draw our right angles there. And our calculator actually gave us one of the solutions. So that's good, 116.1 degrees. But what it did not do is it did not give us the green reference angle. So that's a problem, because we need that green reference angle to help us find this angle over here. But what we can do is we can subtract 116 from 180, and we get our reference angle 63.9. 63.9 degrees. And so we need this angle here. If we add 63.9 to 180, we get our next angle. So that's 243.9 degrees. So those are the two angles that we're looking for. So in the previous problem, the calculator gave us the reference angle, but it was negative. In this problem, our calculator did not give us the reference angle. We had to find the reference angle. But the good news is it did give us one of the solutions. This solution here. So you have to be careful. Sometimes your calculator can fool you. Okay, I want you to try number 21. For number 21, your calculator will give you a solution, and that solution will be the actual reference angle. So try number 21. When you come back, we'll do it together. All right, we're back. So in our calculator, we're going to enter tangent inverse root 7 over 3 because we do not recognize this ratio, so we can't really, we don't really identify that as a special ratio. It's not a special triangle. I'm going to push the blue button, blue second button in my TI-84 Plus, and then the tan button, and then the second button, and then the x squared button, and then 7. Then I'm going to push the arrow button at the right, and then divided by 3, and enter. And we get 41.409 degrees, approximately. So 41 point, I'm just going to say 41 degrees. So that's going to be approximately here. And let me move this angle over a little bit. You can move that up. And so we'll draw the triangle. Sorry, the writing is kind of small there. And we have another triangle in the third quadrant. And I know that because we're dividing the opposite side of the reference angle and the adjacent side. And here we have positive divided by a positive is a positive root 3 over 7. And over here we have a negative divided by a negative is a positive root 7 over 3. Again, I know that's a lot to take in, but that's why trigonometry is generally considered to be pretty confusing. So to find this other angle over here, we're going to add 41.41 to 180, and we get 221.41 degrees approximately. So our calculator gave us a number that is actually one of the solutions. So theta is approximately 41.41 degrees and 221.41 degrees. So there you go. I should have said approximately equal to on this problem here. Sorry about that. To be honest with you, I don't really care if you write approximately equal to. It's not that big of a deal. But technically you should write approximately equal to if you want to be exact. Okay, so if you got that one right, excellent. Good job. Okay, so I want you to try number 22. 22 is a different problem, different type of problem. We know that cotangent theta is negative 12 over 5. Given that information, and also the fact that we know the angle terminates in quadrant 4, so this quadrant here, we're then going to find the values of all the remaining basic trigonometric functions. If you forgot how to do this, that's okay. But see if you can do number 22, and when you come back, we'll do it together. All right, we're back. So it tells us that theta terminates in quadrant 4. So we're going to rotate all the way to quadrant 4. And it doesn't really matter if your triangle is proportionally correct. It just needs to be a right triangle, and it needs to be in the correct quadrant. So we know our triangle is there. The green angle is the reference angle. And we're told that cotangent theta is equal to negative 12 over 5. Now cotangent is the adjacent side, which is going to be positive 12 because this side has to be positive, is to the right of the y-axis, divided by the opposite side, which in this case has to be negative because it's below the x-axis, and this angle is theta. So now we need to find the missing side, which is the hypotenuse, so we'll use the Pythagorean theorem for that. So we're going to plug in A and B. It doesn't really matter which one is which. And we get 169. If we square root both sides, then we'll get plus or minus 13. And is it going to be positive 13 or negative 13? Well, remember, the hypotenuse is always positive. So it's going to be positive 13, so we can then put that number up here. So now we can find all the values that we need using that triangle. So cosecant is the hypotenuse divided by the side opposite the green reference angle. So that would be negative 13 over 5. And secant theta, by the way, we should probably write that a little better. You don't want to get in the habit of writing your negatives so we can't see it very well. Secant theta is the hypotenuse divided by the side adjacent the green reference angle. Sine theta is the side opposite the green reference angle divided by the hypotenuse. Cosine theta is the side adjacent the green reference angle divided by the hypotenuse. And tangent theta is the side opposite the green reference angle divided by the side adjacent the green reference angle. So there you go. So that's how you do those types of problems. If you got that right, good. If you forgot how to do that and you were stuck in some steps, that's okay. Let's try another one of those. So you're going to do the same thing that we did in problem number 22. You're going to have to use the Pythagorean theorem to find the missing side. But be aware, in this problem, we're going to be looking for a leg of the right triangle, not the hypotenuse, a leg. And be aware that your angle terminates in quadrant 2. What does that mean? It means that your triangle is going to be in quadrant 2. So it tells you. Once you find all the side lengths of the triangle, you're going to use those lengths to find these values. Try number 23. When you come back, we'll do it together. All right, we're back. So I'm going to draw a 45, 45, 90 triangle in quadrant 2. It's not actually a 45, 45, 90, but we're going to draw it like that because it doesn't really matter if the triangle is exact. We just want to know where the triangle is. And we're told, well, first of all, this is alpha. And the green reference angle is going to tell us where to put our side length. So sine is the opposite side of the green reference angle. divided by the hypotenuse. Now, we don't know that these are the actual side lengths. We could put 2x and x root 7, but we don't really need to. We're just assuming that x is 1. If you want to, you can put 2x and x root 7, just to be precise, demonstrating that we don't actually know the side lengths. We just know the relations between the sides. And so we need to use the Pythagorean theorem to help us find the missing side. So the Pythagorean theorem is a squared plus b squared equals c squared. And we need the missing side because we're going to find all the remaining values of the functions, the trigonometric functions. So we can let a be 2. It doesn't really matter if 2 is b or a. But it does matter that we plug in root 7 for c because that's the hypotenuse. The hypotenuse always has to go over here. So we get 4 plus b squared is equal to 7. Square root 7 squared is just 7. Squaring is the opposite of square rooting. Then we're going to subtract 4 from both sides. And then we're going to square root both sides. And you don't really have to show the square rooting if you don't want to. Again, you can skip some steps. So b can be positive or negative, at least in the equation itself. So which one is it? Is it positive or is it negative? Well, you tell me. Is this side positive or negative? Obviously, it has to be negative because it's to the left of the y-axis. So negative root 3. Okay, so now we can find all the values that we're looking for. So cosecant alpha is the hypotenuse divided by the opposite side. Secant alpha is the hypotenuse divided by the adjacent side. And we're going to multiply both sides by root 3, and we get root 21 over 3. So we rationalize the denominator. If you need practice rationalizing the denominator, you can go back to class number 2 or my beginning algebra or intermediate algebra course and look at the lessons corresponding to rationalizing denominators. So cotangent alpha is the adjacent side of the green reference angle divided by the opposite side of the green reference angle. Cosine alpha is the adjacent side of the green reference angle divided by the hypotenuse. And we have to rationalize the denominator, multiply both sides by root 7, and we get root 21 over 7. And tangent alpha is the opposite side of the green reference angle divided by the adjacent side. And we're going to have to multiply both sides by root 3. And we get our final answer. So if you got those answers, excellent. If you had a little trouble with some of those problems, that's okay. Again, that's the whole point of this practice test, is to get your mind jump-started. So number 24 is going to be a little different, but it's kind of the same type of problem. This is a point on the XY system. You're going to graph that point, and then you're going to connect the origin in that point with a segment, and that's going to be the hypotenuse of the triangle. See if you can remember how to do this. You're going to draw a triangle and then find the side lengths of the triangle. And if you get stuck, that's okay, but go ahead and try that. When you come back, we'll do it together. All right, we're back. So I'm going to count out 15 and then up 8. Now, the point doesn't have to be exact it would be maybe about there. That's not the, we don't need grid paper or anything like that. So that point, I guess I'll use this color, 15,8. That point is there. So now what we're going to do is draw a segment connecting the origin, and then we're going to draw a vertical. So remember, the vertical always goes to the x-axis, not the y-axis. So this leg is 8 units and this leg is 15 units. That's what that information tells us. That's just the basic definition of rectangular coordinates, the xy system. So now we're going to use the Pythagorean theorem to help us find the hypotenuse. So we have 15 squared plus 8 squared is equal to c squared. 225 plus 64 is equal to c squared. And then we get 289 is equal to c squared. And I know we're dealing with some big numbers here, but you can use your calculator, that's okay. So we square root both sides and we get 17 is equal to c, but it can be plus or minus. Now you tell me, is 17 going to be positive or negative? Well, it's the hypotenuse, so it's always going to be positive. The hypotenuse is always defined to be positive. So that number goes there. So now we can find the values that we're looking for. So sine theta is equal to, and by the way, we need to write theta. Theta is this angle. Sine theta is equal to the side opposite the red reference angle divided by the hypotenuse. So 8 over 17. Sorry about the sloppy writing. Cosine is the adjacent side of the red reference angle divided by 17. Tangent is the opposite side of the red reference angle divided by the adjacent side of the red reference angle. And cosecant is the hypotenuse divided by the opposite side of the red reference angle. Secant theta is the hypotenuse divided by the side adjacent the red reference angle. And cotangent theta is the side adjacent the red reference angle divided by the side opposite the red reference angle. So if you got those numbers, perfect. If you got a little stuck with that stuff, again, it's okay. The purpose of this is to jumpstart your mind so you can get an idea of what you need to review. Okay, we have one more problem. This is the same type of problem we just did. You're going to graph this point, and again, we don't need grid paper. We don't need grid paper to do this. You're just going to find a rough location for that point, and that's going to be enough. Just make sure that you get it in the right quadrant. Try number 25, and I'll leave number 24 in the window, and when you come back, we'll do it together. Okay, we're back. So I'm going to plot this point, and it looks like it's going to be in the third quadrant. We're going to go to the left, -3 root 3, and then down -3. So it might be roughly there. Again, it really doesn't matter exactly where it is. That's not the point of the problem. So that point is on the terminal side of an angle in standard position, which means our angle that we're looking for, well, we're not really looking for the angle, but that would be the angle. That is theta. So we're going to make a right triangle. Always drop the triangle or write the vertical connecting to the x-axis. Never this way. And the green reference angle is the angle that we're going to obviously refer to. That's why it's called the reference angle when we deal with our numbers. So what this tells us is that the horizontal side is negative 3 root 3, and the vertical is negative 3. And I should write the coordinates of that point. The coordinates are negative 3 root 3, negative 3. That's that pink point that we drew. So, again, the proportions of the side lengths, if you don't draw those correctly, I don't really care. It doesn't matter. All that matters is that we understand geometrically what's happening here. But technically this side would be a little bigger than this side. So now all we have to do is find the hypotenuse. So in order to do that, we're going to use the Pythagorean theorem. A squared plus b squared is equal to c squared. So I'll let a be negative 3 root 3. You can let b equal that also. It doesn't really matter. But what does matter is that we're looking for c. We're not looking for a or b. We're looking for c. We have a and b. So this may be a little intimidating for students if you haven't done these types of problems for a while. But remember, that's just negative 3 root 3 times negative 3 root 3. So if you remember how to do that, great. If you don't remember, that's okay, but you're going to want to know this for the test. When you multiply, we can use the commutative rule of multiplication, which means we can multiply in any order. So I'm going to multiply negative 3 and negative 3 first, and we get positive 9. And then root 3 times root 3 would be root 9. Or you can just say 3 if you want to jump right to the answer. So you multiply these, and you get that number. You multiply these, and you get that number. The square root of 9 is just 3. Again, I'm showing way more steps than you really need to show. This is just for your benefit, so you can see kind of what's happening. Then we have 27 plus 9. So that would be 36. So if we square root both sides, we get plus or minus 6. Now you tell me, is it going to be positive 6 or negative 6? The hypotenuse is always positive, so it has to be positive 6. So now that we have all the sides of the triangle, we can find all these values. Sine theta is the side opposite the green reference angle divided by the hypotenuse. So that simplifies to 1/2. And yes, you do have to simplify your fractions if possible. Do not leave the fraction as negative 3 over 6. So cosine theta, that's the side adjacent the green reference angle, divided by the hypotenuse. And you do have to reduce that fraction also. Tangent theta is the side opposite the green reference angle divided by the side adjacent the green reference angle. The negative 3's cancel out, but that denominator is not rational, so we're going to multiply both sides by root 3. And cosecant theta is the hypotenuse divided by the opposite side, so we get negative 2. Opposite side of the green reference angle. Secant theta is the hypotenuse divided by the side adjacent the green reference angle. So we get negative 2 over root 3. We're going to have to multiply both sides of the fraction to rationalize the denominator. And then cotangent theta is the side adjacent the green reference angle divided by the side opposite the green reference angle. So, there you go. If you got that one right, perfect. So that was the class today. We did our practice test. So if you'd like to take screenshots of all the work that we did to help you with your homework or to study for tests, you can go ahead and do that now. Here's screenshot number 1 and number 2, number 3, and number 4, and number 5, and number 6, and number 7, number 8, and number 9. But don't go before you get your homework. Remember, the homework is a practice test. So here's practice test 1 version 2. You did version 1 in class just now. For homework you're going to do version 2, so that's screenshot number 1 and screenshot number 2 and number 3, number 4, number 5, number 6, number 7, and number 8. But don't go before you get the answers. Remember, it's not enough just to attempt the practice test. You have to do it correctly. So here's the answers. Screenshot number 1 of the answers. And number 2. Number 3. Number 4. And number 5. And number 6. So remember, if you don't do that homework, then you're not going to be prepared for the test. You need to do the practice test that we did together in class and this practice test that you just saw for homework. That's the absolute minimum that you need to do to prepare for the test. If you don't at least take these practice tests, then you have no hope of passing the exam. The whole purpose of exams is to figure out what you know. If you fail the exam, then that proves you just don't know what you were supposed to know in this class. So get that homework done, and remember, if you want to get an A or a B rather than just a C, then you need to make sure you know everything that we covered in the previous classes. So I'll look forward to seeing you when we take the test in the next class.